So we're going to finish up by looking at 4.5 part 2. So we're going to be looking again at drawing a line through points. Except this time, we're not going to look at really using a graphing calculator to do it. We're going to use lines that are either already given to us, or I'll help you do it quickly on the calculator. So the goal this time isn't really to learn how to use the calculator again. All right, so a couple things, we're not at the guided notes yet, but a couple things we're going to look at are basically using an equation to predict what's going to happen. So for example, once you write an equation, like using the graphing calculator with the slope and intercept, you can use that formula to predict what's going to happen like later on. So let's say you had a graph that modeled how fast somebody was going, and then the distance it took for them to stop their car. And you had data for somebody traveling 10 miles an hour, 20 miles an hour, and 30 miles an hour. Well, if that's the data that you had, and let's say this was the speed, and then this was the distance that it took to stop the car, once you get the equation of this line, like that, we could make a prediction that says, okay, if somebody was going 60 miles an hour, how long would it take to stop the car? We don't have data for it, but we could make a prediction based on the data we do have. Both of these are what we call different ways of making predictions. One of them is making a prediction between two data points. Like if you had data for 10 miles an hour and 20 miles an hour, maybe you want to try to predict 15 miles an hour. Well, that's a prediction between 2 points we already know. Extrapolation is when we make a prediction beyond all the data. Sometimes extrapolation isn't accurate. It depends on how much data you have. So you have data for 10, 20, and 30. If you made a prediction for 40, it would probably be pretty accurate. But if you tried to make a prediction for like 90 miles an hour, it might not be that accurate because you're making a prediction that's so far beyond all the data you have, it might not be reliable. Right. So we'll talk about those two things. And the third thing we're going to talk about are the two words correlation, which we've already talked about, and then causation. Okay, so I'll explain the difference between the two. All right, so the first point on your guided notes, it says using a graph or an equation to approximate a value between two values that you know, that's called interpolation. Interpolation is when you make a prediction using a line of fit between two values you know. Interpolation is usually pretty accurate because the prediction you're making is surrounded by data points that you actually know. So it's between two. When you use a graph or the equation of the line of fit to predict a value that's outside all the values you know, right? Like I said, if you know the speed of a car and the stopping distance for 10 miles an hour and 20 miles an hour, you try to make a prediction for 80 miles an hour. Well, you don't have any data that really goes that far. So what you're doing is you're extrapolating. That's a prediction beyond all your data. So in general, the farther away that you try to make a prediction from the data that you actually know, the less reliable your prediction is going to be. It's kind of like maybe in the stock market. If you notice a pattern for like Monday and Tuesday, maybe based on different events happening in the world, you could kind of predict what may or may not happen Wednesday, maybe not. But Wednesday's not that far away from Monday and Tuesday. So if you try to make a prediction one day away, probably not going to be that bad. But if you try to use the data from Monday and Tuesday this week to predict what's going to happen 12 years from now, that's not going to do us any good at all. That's just too far away. We can't predict that. All right, so the first problem we're going to look at, I've already found the line of fit. Okay, so what this comes from is somebody used the calculator, and the calculator gave them a number for a slope that was 12 and a y-intercept of 35. And these two variables are predicting something. I'm going to tell you what the x and what the y is in this formula. This formula is used to predict how often you could see the geyser Old Faithful erupt. Okay, it erupts on a schedule. And the schedule that it erupts on depends on a couple things. First of all, if you want to know how long until the geyser is going to erupt from right now, it depends on how long the last eruption was. If the last eruption was like really a long one, then what that means is it's going to take more time to build back up. Think about it like if you just ran up a flight of stairs and then you stopped, right? That might not be too bad. It's not a lot of energy. You just did one flight of stairs. You could probably do another flight of stairs pretty quick. But imagine you went up 40 flights of stairs. You've used up all your energy. You're not going to be able to just go up another 40 flight of stairs right away. You're going to have to rest for a little bit, build your energy back up, and then you'll be ready to do it again. That's how this works. Okay? So y is the time until the next eruption, and x is how long the previous eruption was. All right. So what they want us to do first is approximate the eruption duration if the time until the next eruption is 77. So we just have to figure out where to put that 77 in the formula. Is the 77 the time until the eruption, or is the 77 the duration? Which one is the 77? And if you're not sure, look at what the question is asking you to find, and then it's the other one. Yeah? It's the time. Okay? The question says approximate the duration. So the duration is what you're going to try to find. The 77 is the time. That's the time right there. Time is 77. So where is the 77 going to get plugged in? For what letter? Yeah. Just take the 77 and plug it in for y. So we're using the formula to make a prediction. That's a type of interpolation or extrapolation. Okay, let's fill it in. So 77 equals 12x plus 35. And now we solve for x, which is the duration. What's my first step to solve for x there? Okay, I'm going to subtract 35. And 77 minus 35, 7 minus 5 gives me 2. 7 minus 3 gives me 4. Okay, I'm just going to copy it over here because I have a little bit more room. So 42 equals 12x. And what's my last step? Yeah. Divide by 12. And divide by 12. Okay, and we're going to be solving for the eruption duration, basically how long it's going to go for. Let's see. So we've got 42 divided by 12. Okay, it's about 3.5 minutes. So it's 3.5 minutes. Has anybody ever seen that? Old Faithful? No?
Have you missed our paper?
I have, yes. Yeah, it's pretty neat. They actually have they probably have an app now, but when I went, they had a phone number you could just call, and they would say on the recording, like, there is 57 minutes until the next eruption. They would tell you. Because usually there's like hundreds of people, so you kind of have to wait a while. If it, let's say, like, it just erupted 5 minutes ago, we may have to wait an hour before it erupts again. So you might kind of want to time it so you get there when it's about to do its thing. And it's basically, it's like hot water that just shoots up out of the ground. It goes very high, and you can't really go near it. It's all roped off, probably like several hundred feet around it. So you can't get within a couple hundred feet of it, and then it just shoots up. And sometimes it lasts a couple minutes. Sometimes it might only last like 20 seconds. It might be a short one. But if it's a short one, it'll probably happen again soon. If it's a longer eruption, it may take a little while before it happens again. So any question on how we got 3.5 minutes? We just used our formula to make a prediction. All right, let's look at this one. So the next question says, how long until the next eruption if the previous one, the previous duration was 5 minutes? So what are they telling me in this time? Am I figuring out the time till the next eruption? Or am I figuring out the duration? Which one? Yeah. So they don't tell me a duration in this problem? What are they telling me? Yeah. So that's the question, how long until the next eruption? So that's what we're trying to find. What is the time to the next eruption? How long till the next eruption? So what are they giving me in the problem?
How long the last one lasted?
Exactly. Yep, they're telling me the last time that the geyser went off, it lasted 5 minutes. So that's the duration, 5 minutes. What letter here is the duration? Yeah, X. So this time, you're filling in for the X. You can fill in for either letter. You just have to pay attention to what they give you to know which one to fill in for. Okay, so the previous duration was 5 minutes. So fill in 5 for the duration. Okay, so we're going to have y equals 12x. But remember, we're replacing the x with the duration, 5 minutes. So 12 times 5 plus 35. Okay, 12 times 5 is going to give me 60. And what's 60 plus 35? Yeah, 95. And what would be my label on that? 95 what? Yeah, minutes. So if the previous time that the geyser went off, it lasted 5 minutes, that means you're going to have to wait about 95 minutes for it to go off again. So you go, if you just got there and it already went off, you're going to have to wait about an hour and a half for it to do its thing again. Any questions on that? So biggest thing is, just take the number, fill it in, but make sure you fill it in the right spot. Okay? But read the problem and see where they want you to fill it in. All right, let's try this one. All right, example 2. It says use the line of best fit to predict the following. Now, what goes in that box, that's what you would have to do on the graphing calculator. Okay, I'm going to already have that done for you. So I use the graphing calculator, and I got 21 for the slope, and I got 42 for the y-intercept. And what this formula is used to do is for a certain school, it predicts how many students are in the school based on teachers, or how many teachers based on students. Because usually if you had more students in the school, you would need more teachers in the school. Not always, but generally. So y represents the number of students in the school, and x represents the number of teachers. And again, that would have come from a graphing calculator after I put in all the data. So somebody would have had to maybe do like a survey of different schools and get all that data, and then we could put it into the calculator and find a formula. Right, so it says approximately how many students would be at a school that has 20 teachers. So we know 20 is what we're filling in. But what are we filling the 20 in for? Which letter? Yeah. X is teachers. And in the problem, they're telling me I have 20 teachers. So you're going to fill in 20 right there. And that's going to predict how many students would be at the school. Again, it's just a prediction. It doesn't guarantee that if you have 20 teachers, you have exactly this many students. It's a guess based on that formula. So y equals 21 times 20 plus 42. All right, and let's see what we get. So 21 times 20 plus 42 is 462. And what should be my label on that one? We just saw 462 what? Students. Yep. So based on this formula, if you had a school with 20 teachers, there would be about 462 students at this particular school. All right, let's try it this way. So it says, how many teachers would be at a school with 335 students? Same formula, but they're giving you a different number to plug in. They're telling you you have 335 students. So where does the 335 get plugged in? Yeah, that's the y. So this time we're going to fill 335 in for y. And we're going to solve for how many teachers you would need at that school if you had 335 students. So 335 equals 21x plus 42. Okay. What's my first step to solve for the number of teachers? Yep. Okay, so subtract 42 from both sides. And we've got 335 minus 42 gives me 293. And what would be my last step? Yeah. Yep, divide each side by 21. So divide by 21, and we get about almost 14 teachers. Right? So if we were going to round that to the nearest teacher, that would be about 14 teachers. Because that's 9.5 would round up to 14. So I'm going to put about 14 teachers. Usually when you do a problem about people, you generally round it to the nearest integer because we don't really talk about like 14.7 teachers or something like that. You either have 14 teachers at the school or you have 15 teachers. We don't generally talk about in between. Any questions on? Yeah. Yep. All right. So now think about the teacher problem and the number of students that we just did. Do you think in general that there's a connection between how many students are in the school and how many teachers will be in the school? For most schools. What do you think? Think Lexi? All right, what do you think would be the connection between students in a school and how many teachers in the school?
The more students in the school, the more teachers there would be.
Yeah, I would say generally that sounds pretty reasonable. The more students in the school, probably the more teachers are in the school. Now, my next question is that a guarantee? For example, if we take in 20 new students today, do we automatically have a new teacher? No, it's not a guarantee. So there might be a connection, or there might be a correlation between the two, but taking in more students will not automatically cause a new teacher to just appear. That doesn't happen. So that's what we're going to look at now. Is there a connection between two things? And if there is, does changing one of them automatically make the other one change too? Yeah? Yeah, the same. Here's another example. Think of doing like exercise. Take the same exercise. Say like, riding a bike. What do you think would happen between the time you spend riding a bike and the amount of calories you burn? Do you think there's a connection between the two? Yeah?
Yeah, so the longer you ride your bike, the more calories generally.
Yeah, I would say the more time that you ride your bike, the more calories in general you're going to burn. Keeping everything else equal. It's a flat surface, you ride the same speed, things like that. Now, let's see if that's a causation. If you ride your bike longer, will you burn more calories? Like pretty much automatically. If you keep riding, are you going to burn more calories? Sean? Yeah, that's a causation. If you ride the bike longer, you are guaranteed to burn more calories. So riding the bike longer causes more calories to be burned. Again, assuming it's the same speed on the bike and things like that. All right, so changing the time you spend on the bike automatically changes the calories you burn. That's a little different than students and teachers. Changing the number of students in the school doesn't automatically change the number of teachers in the school. It's not automatic. All right, so let's write that down. All right, so on the back of your guided notes at the top, it says, when a change in one variable causes a change in another variable automatically, that's called causation. So you change the amount of time you spend on the bike, you automatically change the amount of calories you burn. They are directly caused, like there's a causal relationship between the two. And if one thing is caused when you change the other, then you have a very strong correlation between the two variables. So correlation means there could be a connection between the two. Causation means one thing causes the other thing to happen automatically. Here's another example. I was just looking over at my desk and thinking. So let's say the amount of ink left in the printer and the amount of pages I print. Do you think that there is a connection between the amount of pages I print and the amount of ink that's left in that printer? What do you think would the connection would be?
Well, more people you print, more ink you use, so use more ink.
Yeah, the more pages I print, the more ink I'm going to use. Now, does that pretty much, assuming I don't print blank pages, does that automatically happen if I don't print blank pages? If I print something, will I automatically use ink? What do you think, Jacinta? Yeah, that's called a causation. Printing will cause more ink to be used. There's no way I can print and not use ink. Again, not printing blank pages. So that's a very strong correlation between how many pages I print and how much ink is left in that printer. But the other way around isn't necessarily true. Okay, so you guys already have this printed on your guided notes. Just because two things are correlated, it doesn't mean one causes the other to happen. There's an example of two things that are might be correlated. You tell me. The amount of, let's say, trying to think of a good example of a correlation. All right, let's do this one. How about how much schooling you get and how much money you make? Do you think that there could be a connection between like how long you go to school for and how much money you make, whether it's a trade school or whatever kind of school? But do you think there could be a connection there? Tirza, what do you think? No? So you think like, for example, if somebody had like no education versus like, you know, they went all the way through like a, you know, like a trade school, got all these certificates, you don't think that one person might look better to an employer than another, like more likely to be hired or something like that? Yeah?
If you have more school, you could possibly make more money.
Yeah. I would say whether the schooling is, you know, some type of certificate or like a degree or something, but I would say if you looked at how much time somebody spends going to school and the licenses they earn, like whether it's an electrician or something like that, I would say people that earn those licenses and get degrees, I would say probably there's a connection that they make more money than people that don't earn the license. Like picture an electrician that's like a journeyman and then a master electrician. I bet the master electrician makes more money than a journeyman because they have a higher license. They did more schooling or whatever they had to do to earn that title. Now, do you think that going to school more would guarantee you make more money? No. Just because you go to school more, it doesn't automatically cause you to get more money all of the time. There might be some jobs that it does that, but you could go to school and for 20 years and, you know, get all these degrees, but you might not make more money. It's not a guarantee. So just because two things are connected, it doesn't mean one causes the other. All right. So on the test, I'm going to give you some different scenarios, and we're going to look at them and see whether there's a correlation. And then if there is a correlation, does one thing cause the other? Yeah. Yeah. All right, so we kind of went through this one a little bit. The time that you spend exercising and the number of calories that you burn. So this is example 3A. Do you think there's a correlation? Meaning, could there be some type of connection? Not does one thing cause the other, but do you think there's a connection? What do you think, Lexi? So explain to me what you're thinking.
I think there's a correlation.
Okay, how come?
Because if you exercise more, then you burn more calories.
Yeah, and that's basically what we want to write down. So I would say here a correlation seems likely because the more you exercise, the more calories you could burn. All right, so I lost my spot. Correlation seems likely because the more you exercise, the more calories you could burn. And when we do something like this, we assume we're not going to change the exercise, because then if you say, well, yeah, what if I went from like climbing wall climbing to then riding a bike? Well, yeah, climbing a wall is probably more calories than riding a bike, but we assume that when you talk about something like this, you do the same exercise, you don't switch the exercise, and you don't change how fast you're going. You keep everything else the same. So it definitely seems like there is a correlation. And do you think this one is causal? Do you think there's a direct connection? If I change the number of minutes I exercise, is it going to automatically change how many calories I burn?
Yes.
Yeah, there's no question. If you keep everything else the same, I would say this is also what we call causation. Changing one thing is directly going to change the other. So we could also say this is a causal relationship. Now, how about, here's another, actually this is a good one. How much time you spend studying and the grade you get on the test. Do you think there's a correlation between the time people spend studying and the grades they earn? What do you think? Yeah?
Yes, because like the more time you spend studying, the better you'll probably do the test.
Right, and the key thing he said is probably, right? The more time you spend studying, the better chance you have at doing well on the test. But if you study for more minutes, does it automatically make your grade higher? Like, is it a guarantee? If you study 10 extra minutes tonight, you're going to get 10 points higher on the test tomorrow. No, it's not causation. It doesn't automatically cause your grade to go up. So yes, there's a connection, but it doesn't cause the other one to go up automatically. All right, let's look at this one. The number of banks and the population of a city. Okay, like the size of the city. So let's say you don't want to look at this for just your city. Then you looked at this for every single city in the United States. Do you think you would find a pattern between the size of the city and how many banks are in the city? What do you think? Yep.
Yes, because the more people are in the city, the more banks on you.
Yeah, and I would say that's probably not just true of banks. It's probably true of restaurants, like department stores. In general, I would say the bigger city you have, the more of everything you're going to have in it. The more, more houses you're going to have in it, probably. Not a guarantee, but I would say yes, there probably is a correlation here. So what's the first question? Tell whether there is a correlation. So I would say yes. Correlation seems likely. Now, do you think the relationship between the population and the number of banks is causal? If 20 more people move into the city today, does that automatically increase the number of banks on that day? Jacinda? No. Having more people doesn't all of a sudden cause a bank to just pop up. It doesn't work that way. So tell whether correlation is likely. Is it causal? No. So I would say this is is not causal because more people does not automatically cause a bang to be created. More people does not automatically. That's the key for it to be causal. It has to be automatic. When you change the first thing, there has to be no way the second thing can't change. It has to change automatically. And in this case, that's not true. That's how I would describe it. So any question on that? For some people, sometimes this is a little hard because it's not, this is more of like statistics, which there's more gray area. It's not like solving an algebraic equation where you do step one, you do step two, here's the answer. Sometimes there's more interpretation to this. So I'm going to try to give you ones that I think are, have a good day. You too. I'm going to try to give you ones that I think are relatively clear cut, not something gray. All right, let's look at a couple more. So same directions for example 4. Tell whether there is a correlation. And if there's no correlation, you can stop right there. If there's no connection between the data, then one of them definitely doesn't cause the other to happen. So if you figure out there's no correlation, it's definitely not causal. If there is a correlation, it could be causal. You have to think about it. All right, let's look at this one. The amount of time spent talking on a cell phone and the remaining battery life. Do you think there's a connection between how much time you talk on the phone and how much battery power is left in the phone? What do you think? Yeah?
I think so.
Yeah, I would say that a correlation is likely there. And again, we assume that you're doing the same thing on the phone the whole time. It's not like for 5 minutes you play a game and you're watching a video while you're talking to someone. You just, you're talking on the phone and you just put it down and let it sit there. So you do the same thing. How about, is it causal? If you continue to talk on the phone, will it automatically cause the battery to go down? Or could the battery not go down if you keep talking on the phone? Yeah? Right, you don't plug it in halfway through. That's changing how we're doing this. So, yes, this is causal. If you put the phone on and you talk and you just leave it sitting there, it will cause the battery to go down. There's no way to avoid that. Okay? So, yes, that is causal. Okay. Let's look at another one. The height of a toddler and the size of their vocabulary. So do you think there's a connection there? If you graph the height, how tall a toddler is, or even think of it like a person. It doesn't even have to be a toddler. Just think of people in general. Do you think there's a connection between how tall somebody is and how many words they know? Yep. No, I don't really think there's much of a connection there. I mean, assuming you're comparing people of the same age. You don't want to compare somebody who's 2 to somebody who's 70. That's different. But I mean, if you compare all 20-year-olds, like your age is 20, I don't think somebody that's 7 feet tall versus somebody who's 4 feet tall would necessarily know more or less vocabulary. So I would say no, correlation doesn't seem likely, and that automatically rules out causing. If 2 things are not connected, then one of them definitely doesn't cause the other. So no. And if you think differently, let me know. I mean, I can listen to a different argument if you think that that's true, but I don't think there's much of a connection. Okay, and the last one. The weight of a dog and the length of its tail. So if you think like, because a dog is heavier, it has a long tail. Yeah? No, that doesn't really, I can't see much of a connection with that. Maybe the weight of a dog and like how long a dog is, maybe. I could see more of a connection with that because if you weigh more, the dog is probably longer, most likely. But the length of its tail, no. All right, so tomorrow we'll take a look at the homework from 4.5 part 2, and then we'll do a review worksheet for the test. And if people want to practice another graphing calculator one or just try it again, I'll take those out so you can try it. Okay, so just make sure you do the homework 4.5 part 2 on school.